Okay, so you're going to need your notes that I gave you in class today on rational and irrational numbers. The first thing we're going to do is some definitions, and you're actually going to need to add this definition to your notes up top here. A rational number. A rational number is any number that can be written as a fraction. So that's actually most of the numbers that we work with normally. Any whole number can be written as a fraction. All you have to do is put it over 1. So 5 would be 5 over 1 as a fraction. Obviously fractions are already fractions, so that's fine. Whether they, doesn't say that they have to be, the small number has to be on top. You can have an improper fraction. It's still written as a fraction and it'll still be a rational number. Terminating decimals. The word terminating means that it ends. So any decimal that ends, like 1.23, done, stops at the 3. That's considered a terminating decimal. That can be written as a fraction. In fact, the easy way to do this, just read this. Rather than reading it as 1.23, we could also read this as 1 and 23 100ths. That's your fraction, 23 over 100. So there's actually a mixed number, 1 and 23 over 100. So yes, that's rational. And then it turns out that repeating decimals. Any decimal that repeats, we could write as a fraction. That's something you'll actually learn how to do in high school, but we definitely can do that. So all of these numbers, which is pretty much any number you've ever worked with for the most part, is a rational number. An irrational number then would obviously be a number that cannot be written as a fraction. And so if you look at all these things that can be, turns out really the only thing that can't be written as a fraction is a decimal that does not repeat and does not end. You could probably think of one real quick that we just talked about last week. That would be pi. That is a decimal that never repeats and never ends, and so that is an irrational number. Now real numbers, it's basically every number we know. It's all the rationals and irrationals together. So they're all real numbers. Alright, so classifying them. No, these first couple ones are pretty easy. If you look at 4/5, it is a fraction, so that means it has to be a rational number. If you were to make it into a decimal, 4/5, remember you change decimal fractions to decimals by dividing, top by bottom. 4 divided by 5 will give me 0.8. So that is a terminating decimal. (7/20) again, it's a fraction. It has to be rational. If you looked at it in decimal form, again divided 7 by 22, you would get 0.318118. In other words, the 1/8 repeats. So we write that as 318 with the bar just over the 1 and 8. If you remember how to do the repeating decimals. And so that's okay, because we said that repeating decimals we would be able to write as fractions. So, right? So we have terminating decimal and a repeating decimal. They're both rational. Now this last one, square root of 2. In order to do that, 2 is not a perfect square, so we would have to use our calculator to get what that is equal to. And if you use your calculator, what you're going to see is the square root of 2 is 1.4142, and it keeps going, 1, 3, 562. And the only reason that it stops is at 2. It's not that that's what it's equal to. It stops right there. The calculator ran out of room. And so this one is non-terminating. It doesn't end. Keeps going forever. Also, you notice it does not repeat anywhere. You do not have the same thing happening over and over again. So it's non-terminating, and it is non-repeating. And so this one would be an irrational number. There is no way that you could write that as a fraction. Okay? And if you look at this box over here, this is extremely important, this box. So put a circle around this, star it, something. This is very important information. It says, notice that if n is a positive integer and is not a perfect square, then the square root of n and the negative square root of n are irrationals. If what is under the radical sign is not a perfect square, which you should have memorized the first 20 of those, all those other numbers, besides those 20 perfect squares between 1 and 400, all those other ones are irrational numbers when you take the square root. They will be decimals that go on forever without repeating. And so that is where most of our irrationals come from, is when we take a square root. That's really important to remember. So now we look down here at the bottom. It says your turn now. Well, these are pretty easy. 9/20, that has to be irrational because it's a fraction. Okay? Number 2 here, square root of 13. I just read this, right? If I have a radical sign, if I have a square root, and what's underneath is not a perfect square, then this is irrational. So I just have to ask myself, is 13 a perfect square? The answer is no, it's not. So this one is going to be an irrational number, because what's under the radical sign is not a perfect square. So why don't you pause the video, try 3 and 4 on your own, see if you can get those, and then when you start it up again, I'll give you the answers. Okay, so number 3, again, just like number 1, that's going to be irrational just because it's a fraction. Okay, sorry, a fraction, that's the definition of a rational number. Number 4, I'm going to go back up to this here, say, okay, if what's underneath is not a perfect square, then it's irrational. So look at 81. Is that a perfect square? Yes, it is. The square root of 81 would be 9. So again, this is actually a rational, because what's underneath is a perfect square. Okay. While we're working on this, we need to talk about how to compare numbers that have repeating decimals. Okay? This can get a little confusing at first. So the best thing you can do, if I'm going to order these decimals, 0.63 repeating, 0.633, 0.63 with just the 3 repeating, and 0.636 all repeating, the best thing to do is expand these decimals out. They say to go to 6 places, so that you can see where they're going to be different. So 0.63 with the bar over both of them is 63, 63, 63. Okay? 0.63 with just the bar over the 3 is going to be 0.6, 3, 3, 3, 3, 3. Only the 3 repeats. 0.633, and it just ends. After it ends, we can put in zeros. So that's 0.6, 3, 3, 0, 0, 0. And 636 with a line over both, all of them, is 636. And repeat that, 636. And so least to greatest. Well, they all start with 6-3, so I look at the third decimal place. That one's got a 6, a 3, a 3, and a 6. So obviously this one here and this one here are going to be smaller. They have a 3 in the third spot. Go to the next decimal place, I have a 3 and a 0. So this is my smallest, right? 0.633. That's going to be my smallest one. Which means this one has to be my next smallest, with repeating on just the 3. Now the other two both had 6's in the third place, so I go to the fourth one, I got another 6, and this one I have a 3, and so this is definitely going to be smaller than that one, so I have 0.63 both repeating. And the biggest would be the 636, all repeating. So whenever you want to compare these repeating decimals, the best is to expand them out a ways so you can see where they're actually different. Okay. Now we just have one example problem of where you actually use irrational numbers. So this one says the equation s equals square root of 27d will give you the minimum distance that it takes a car to stop on dry pavement after applying the brakes. In the equation, d is the stopping distance in feet of a car that is traveling at a speed of s miles per hour. So in other words, they could use this if there was a car crash or an accident, and they could see how long it took a car to stop by the skid marks. They would be able to use that distance in this equation to figure out how fast the person was driving, so they know if the person was actually driving at a safe speed or if they were speeding, and that's what caused the accident. And so it says if a car's stopping distance is 138 feet, how fast was the car traveling? Okay, so we have the equation. The 138 feet is the distance, so that goes in for D. And then I just solve this problem. If I multiply those together, I get 3726. And that's under the square root sign. So then I can use my calculator, I take the square root of that, I get 61.0409, and it keeps going. So I'm just going to round it off and then say it was going about 61 miles per hour. So if the person was traveling on the highway, that's fine. If they're traveling through town, that would be a problem. Okay? So this is one place that they actually use these square roots. They use irrational numbers to get an idea, and you could try this one as well. Go ahead and pause the video and try it and see what you get, and then when you start again, I'll tell you what the correct answer is. Okay, so the answer to this one would be about 73.48 miles per hour. So a person going right around 73, which is about how fast people drive on the highway. And you see it takes a long time to stop when you're driving that fast. So it's important to follow speed limits.